Thank you. So I'm super excited about AI, machine learning, deep learning, and what I want to do today is share with you a couple of major trends I'm seeing in deep learning, so that if you're wondering, should you use deep learning or not, two things you should be aware of. And then we'll zoom out from the technology to talk a bit about how I think AI technology will impact teams, and then zoom out further to talk a bit about how I think AI will impact industries. And I want to do something slightly different. Later in this presentation, I'm going to try to have you do a poll on your cell phone. So take your cell phone, fire your web browser. I don't ever work with this many people in the room, but we'll try. And if I say something that you feel passionate about, feel free to tweet at me as well during this talk. Before jumping into deep learning, just to mention Spark at Baidu. Baidu loves Spark. We use it extensively with some tens of thousands of machines running Spark. And I guess later today, some of our engineers are also going to talk about how we run our deep learning platform specific on Spark. We often have a workflow where we do the data pre-processing on Spark and then send it off to our deep learning platform. So see, come to the 3:10 presentation, 3:10 p.m. presentation if you want to hear the details. I want to focus this presentation on AI and deep learning. So the ideas of neural networks have been around for many decades. I think I implemented my first neural network when I was 16 years old, right? Did an internship at a university in Singapore. But they've only really taken off in the last 5 years. So why is that? I often like to make an analogy between building deep learning systems and building space rockets, right? So here's what I mean. What's a space rocket? Space rocket is basically a huge engine together with a lot of fuel. And you need both to be big if you want to build an interesting rocket. If you have a huge rocket engine and a tiny amount of fuel, your rocket won't go very far. If you have a tiny engine and a huge amount of fuel, you probably won't even lift off. The only way to build a good rocket, interesting rocket, is with a huge engine and a lot of fuel. The analogy to deep learning is that the rocket engines are the huge neural networks that we're now finally able to train because of the huge amount of computation we have, and the fuel is the huge amounts of data that we now have. So one case study, one of the projects I've been passionate about is speech recognition. Jeff mentioned one of the projects, Google Brain and Speech. When I was leading the Google Brain team, the first project I decided to partner with was Google's speech recognition team. It involved some of that work that Jeff talked about. But at Baidu, we're trying to build maybe the next generation of speech recognition system. So historically, speech systems have used a pipeline like this, where you have many complex features and recognize phonemes, figure out language model, and so on. Starting around 2011, researchers at Microsoft, really leading, working with Jeff Hinton, replaced part of the pipeline with a deep learning algorithm. At Baidu, this is what we did at Google as well when I was there. At Baidu, we decided to say, let's blow the whole thing away and replace this maybe decades of hand engineering systems with a neural network. I've simplified the picture, but in practice, our neural networks look a bit more complex than what I draw for illustrative purposes. But this is our huge rocket engine, right? Very large neural network that inputs audio and tries to output a transcript. How about the rocket field? The largest data sets in academia that people use for speech recognition is about 2,000 hours of data. We now routinely train on 45,000 hours of data of speech, so far more data than you see in academic research papers. And with this formula of a big rocket engine, a lot of rocket field, today our speech recognition system outperforms human-level transcription for Mandarin phrases, short Mandarin phrases taken out of context. I think it's quite remarkable. And all the years of work on speech recognition, I think many people don't understand the difference between 95 and 99% accuracy. I think that that's not an incremental 4% improvement. Is the difference between most of us barely using speech recognition, which is maybe where we are today, versus all of us using it all the time and not even thinking about it. The whole world is moving to these mobile devices. Humans weren't designed to communicate by poking at things with your fingers, and I think that we are actually about to see a massive revolution with many more speech-powered devices, and Baidu and many other companies have been developing these. Thanks largely to deep learning, I think over the past few years, our speech systems word error rate has gone down dramatically, and we've seen really with that a commensurate growth in users. I'm actually quite proud that since the beginning of last year, our speech recognition usage has more than tripled. So this is just one of the examples of the projects that I think will undergo a revolution because of modern deep learning. So what do you need to take away from this, right? I think that a lot of hype about deep learning, should you use it or not? If you remember one chart from this presentation, I hope it's this one. I think this really abstracts away from a lot of the hype about deep learning and maybe summarizes my understanding of what really the single biggest impact, although there are many, for why deep learning is working. If you take a traditional learning algorithm, like a support vector machine or logistic regression, and you feed it more and more data, you find that for the most part, the performance plateaus after a while. It's as if most traditional learning algorithms don't know what to do with all the data we now have. If you train a small neural net, it plateaus later. Train a larger neural net, plateaus later. And with a very large neural network, with enough data, theoretically, you can approach Bayes error rate, or theoretically optimal error rate. So when people ask me, why is deep learning taking off? There are a lot of reasons, including algorithmic innovation, many other reasons, but this is the picture I tend to draw when people ask me why deep learning is finally now taking off after all these years. So I think that society has actually accumulated a lot of data. So in recent years, a lot of the challenge of deep learning has been figuring out computational scale. So a little bit of my personal history, maybe. Many years ago, deep learning was run on CPUs. We used to train models with about 1 million connections. Then, starting 2008, my team at Stanford started to move the work on the GPUs. It was very controversial at that time. And we could train a bit bigger models. 2011, when I founded and led the Google Brain project, we started to use Google's cloud to scale this up to another level, to a much larger level. I had the great pleasure of working with Jeff Dean back then. And more recently, first at Stanford and at Baidu, we've been trying to build even bigger systems, relying on HPC or supercomputing technology, really very large numbers of GPUs. And to give you a sense of the models, to train one of our speech models today takes about 10 exaflops and costs us about $100 worth of electricity. And we routinely train on 4 terabytes of data, which is not that large by our standards. And so today, our engineers routinely train jobs on maybe 60, maybe 32 GPUs at a time. That's a fairly routine workload for us when training large models. And we find that by building an HPC team, a supercomputing team, we're able to get very, very good, almost linear speedups, even when using very large numbers of GPUs, at least in ideal cases. In previous presentations, talked a lot about the rise of HPC for training. One thing I haven't talked as much about is the rise of HPC for inference, for serving these models, right? So when you build a supercomputer, with 100 GPUs and you train a huge model, how do you put this onto the cloud and serve it? So historically, when we have CPU servers for serving, you have a CPU server, maybe run 4 threads or 20 threads on a CPU server, and if you have 4 users that show up to say something to the cell phone, say, you feed data from 4 users and feed it into your 4 threads, and do 4 threads of computation and give you 4 outputs. This is historically how we've architected our server infrastructure. But we found that for our large speech models, this type of architecture did not scale with CPU-based computation. So we've started to, this is in deployment, we're deploying GPUs, not just for training, which everyone has been doing for quite some time now, but deploying GPUs for production, serving real-time user queries. So one of the interesting tricks we developed for that is a technique we call batch dispatch, where instead of serving users one at a time, we might wait around a little while until we have 4 users give us their data. Then we take the 4 users' data and stack it into a big matrix, and we feed 4 users' data simultaneously into a GPU, which can make very good use of SIMD parallelism to compute on multiple users' data at a time. You then separate it back out, and mathematically you get the same result as if you had done 4 separate computations, but this takes much better advantage of GPU SIMD parallelism. And so we have a production speech, production computer vision systems, quite a few systems that are using this batch dispatch, and it's allowing us to put into production much larger models than we were previously able to. So I think scalability, right, has been, in my mind, the number one driver of progress in deep learning in the past several years. And I think that, in my mind, there's a second most major trend is learning complex outputs. So here's what I mean by that. Historically, in machine learning, we used to do things like spam classification, predictive. We used to click on an ad, image recognition, and our outputs were often an integer, like 0 or 1, or an index or a real number. One of the exciting developments in the past several years has been deep learning algorithms that can learn much richer outputs. So speech recognition was one where we found that we can have a speech system output a transcript directly. Image captioning, actually Jeff talked about this. This was work first done by one of my team members, Wei Shi, I think, where we can input an image and directly output a caption. Other examples, input an English sentence, output a French sentence. Actually, that third one was first done by Google. You can also input an ungrammatical sentence, maybe written by a less fluent speaker, output a corrected sentence. This research my students are doing at Stanford. But so I think if you had to ask me what are the second major driver in terms of where you might be able to exploit deep learning, I think there's this trend toward deep learning algorithms, not just outputting an integer, but now outputting much richer things like an English sentence. And the major limitation, really the huge limitation of all of this is that you need lots of labeled data. This is why I think today a lot of us are doing research on unsupervised learning and other forms of learning. I hope for a breakthrough there. I'm optimistic we'll have a breakthrough where we need less labeled data, a lot of data where we have pairs of both the input and the output. But even if there is no breakthrough, and I'm really hoping and optimistic about breakthrough, but even if there is no breakthrough, it's clear that just the supervised learning input-output mappings like these is driving huge amounts of value today. And this is why I've been saying, I think AI is the new electricity. Just as just as electricity, something like 100 years ago, transformed so many segments of our industry, from manufacturing to retail to food, refrigeration to transportation. I think that AI, I'm optimistic today, even with this simple formula, naive formula of supervised learning on tons of data, I believe we're in a position to transform many industries. So take out your cell phones. Let me try something different. Take your cell phones and open up your web browser and go to this URL. Before going on, I'm actually curious. All of you, many of you are seasoned engineers, leaders, managers. I'm actually curious for these different segments of industry, which one, if you had to bet, do you think will be most transformed by AI in the next few years? And then I'll share the results with everyone in the audience as well. Although I think if once you submit, you really see the results as well. Oh, is this working? Oh. Wait. Are people laughing because we just brought down the network or the... I see. All right, you know what? I think it was a bad idea to try to such a huge audience. Let's move on. When I look at each of these, actually, I'll put a URL later. You guys can do it later. When I look at each of these industries, I feel that we actually have a decent chance of transforming most of these industries, some in the short term, some in the longer term. But I want to share with you some of I do want to talk about, Baidu now has, I think, hundreds of projects using deep learning. I'll just highlight 3 that I'm most excited about as examples of how AI deep learning, I think, will be transformative for a lot of people. One of the projects I'm most proud of is DuLight project, to try to help the visually impaired. So talk about image captioning, input an image, output a caption. Who needs that? Well, one of the types of people that could most use that is the visually impaired. So we've been working on a device that is a little headset with an earplug and camera that we've been providing to vision impaired individuals. So you can take a picture of what's in front of you, use computer vision, or fall back to a human if computer vision has low confidence, to try to read out to you, what you're seeing. And this, we've been doing user testing with some of the societies to help the vision impaired in China, and the user response has been incredibly positive. So I think of this as an example of the transformative effect of this type of thing. One other example of a project we worked on, we've done way more work on this than we've actually talked about it publicly, is healthcare. So this is actually, this is live on the website, but if you're sick, and I guess if you speak Chinese, you can go to our website and enter free text entry of your question or symptoms, and then hit submit. We then pop up a message saying, wait 15 minutes, we'll have a human doctor come and respond to your question for free. It's a free service we provide. But we learned that 15 minutes is an eternity to wait. Like if you are sick, if your child is sick, who wants to wait 15 minutes to see a doctor or to have a doctor respond? So the other thing we did was apply a deep learning algorithm that inputs your free text query and tries to output a suggested reading, really suggested possible diagnoses, so that while you're waiting these 15 minutes, you could read online articles. We have an asset very similar to Wikipedia in China, so that you can read some articles about possible diagnoses and maybe get reassured when you start thinking about while you're waiting for the doctor. Third example, let's just touch on. It's autonomous driving. So, over my life, I've worked on a lot of cars. Right? On the left are pictures of 4 cars. The Stanford car that my friend Sebastian Thun had built that I helped work on. Upper right is my personal Honda Accord. My students at Stanford instrumented that. Car my students built and the car we built at Baidu. And I have to say, having worked on a lot of autonomous vehicles over the last decade plus, starting with really the Stanford cars, is really only in the last year that for the first time in my life that I feel like we have a shot at making autonomous driving a reality. I guess you've seen videos like these. So it was last December, my team in China announced that we're driving the streets of China. And I think we think about autonomous driving a little bit differently than most other organizations have been doing it. Rather than trying to build cars that are safe everywhere, we believe we should start with small autonomy-enabled regions, maybe a bus route, maybe a city, and grow the region. I think that's much more promising. Second, I think we need modest changes to the road infrastructure. Rather than the way to make autonomous cars safe is not to make them drive just like humans, right? So for example, if you drive along and you see a construction worker do this, you should stop. If a construction worker does this, you should go. I think despite all the progress in AI, I don't think any vision system today can reliably distinguish between this and this at the level of accuracy you need to make that absolutely critical decision. So our strategy is to invest in modest changes to the infrastructure, such as give that construction worker a wireless beacon. And finally, I think that it's a mistake to try to make autonomous cars look just like human-driven cars by making our cars visually distinctive and making them predictable. Predictability, even more than cleverness, is important for safety. If a car's predictable, that really drives safety. And this is why we painted our cars as somewhat, I don't know, I got a lot of criticism from my designers about picking not the prettiest design, but my goal was not pretty, it was distinctive. But with things like these, and of course, the heart of our project is deep learning, or really technology, machine learning, deep learning. We hope to commercialize autonomous vehicles within 3 years and mass produce within 5 years. And on our team, our rallying calls the number 3,000, right? 3,000 deaths per day from autonomous cars. This is why we feel a strong sense of urgency to make this happen as soon as possible. So those are just 3 of the projects I'm especially excited about. But at Baidu, one of the fun things I get to do is work on a lot of projects. Web search advertising driven by deep learning. We do a lot of work on consumer finance, extending loans to people that really need small amounts of money. Fraud detection. We provide a lot of on-demand services, like food delivery and so on, that we optimize using machine learning. A lot of things. And so I think this is why I think that I really hope that over the next few years, AI will go well beyond helping technology companies, like many of us work at, but that it will actually go and transform many industries. So, the last thing I want to do is maybe make some predictions about this maybe future of AI and how this might affect your companies as your companies and other companies as AI is rolled out more broadly. And often refer back to the early days of electricity, or sometimes the early days of the internet. And I think this is a picture of a reconstruction of a plant that used to be steam powered. Steam powered engines were power distributed via a physical pipe, a physical thing that ran down the entire length of the building that physically rotated. Right? And the way you distribute power before electricity was you have physical things moving throughout the entire building to physically distribute power by having a rotating column span the entire length of the entire factory. So in the early days of electricity, companies in the US used to hire a VP electricity and sprinkle on some electricity onto your business, like add a few motors there, add an electric light there, and that was great. That had a huge impact. But over time, what we realized was we couldn't just sprinkle on electricity. Instead, you should redesign the entire manufacturing plant to use electricity, and then you had even larger gains. I feel like right now we're in the VP electricity phase of AI, and in fact today we have companies hiring, I guess, chief information officers. Some of those roles are transforming into chief data officers, and I think a lot of companies, including us at Baidu, frankly, to some extent, is building centralized AI functions to help the whole company. And I think to some extent, I feel a little bit like I'm the VP of electricity for Baidu, right? Kind of managing this AI thing. And we've already seen tremendous gains in terms of much better experiences for users, much better revenue by sprinkling on AI to existing businesses. But what I'm starting to see is that leading tech companies are starting to evolve toward what I hope will be the next phase of AI, which is where we deeply incorporate AI into our businesses. So some specific ideas. Maybe to make another analogy, in the early days of computers, we thought that computers were about digitizing emails and digitizing calendars. But that's not what an internet company is. An internet company behaves fundamentally different than a non-internet company. I think the deeper transformations that the internet companies have is we tend to push power down to the engineers and let engineers make decisions and have less top-down direction. We have strategies that exploit network effects. And we think about network effects as internet companies in a very fundamentally different way. We think about platforms, very different than non-internet companies. I think AI will have an equally transformative effect on corporate strategy. So for example, what I see in companies today is that data is the defensible barrier to many new businesses that we're trying to build. Today, I rarely assume that any of our competitors is more than maybe a couple years behind us in terms of algorithms, or hardly anyone among the leading tier of companies is more than 1 or 2 years ahead or behind of others in terms of algorithms. But many of us have unique data assets that are very difficult for competitors to copy or for us to get a competitor's data assets. And so I'm seeing an evolution of corporate strategy where, for example, actually at Baidu, we now have fairly sophisticated strategies for how we organize and acquire data. And today, I sometimes launch products where my main motivation for launching a product is not revenue, is actually to acquire data. And so we do see this evolution of corporate strategy. And so I hope that over the next coming years, many of you, those of you especially in or growing to leadership roles, will really help companies first be the VP of electricity, be the VP of AI for your company and lead that transformation. But I think there is this next phase that I'm excited about our organizations going through. And finally, just to wrap up, what can I say? I think we're superpowers. When I look at industry after, one of the games some of my friends and I like to play is we challenge each other to name a segment of industry that we don't think AI will transform in the next decade. And I honestly don't have many good answers to that question, right? Try to think of one. My favorite answer is my hairdresser. I don't know how to use AI to put my hairdresser out of a job. But outside of that, I think that AI will create so much value for corporations, for users, for us as engineers. And I think that when you're able, when you know AI, when you know distributed computing, when you know HPC, which we invest heavily in, you can go and transform entire industries and help blind people see. And if that isn't a superpower, I don't know what that is. So I hope that really all of us with our superpowers will go forth and do our best possible work for humanity. Thank you all very much.